Hey guys, welcome back. Today we're going to continue to talk about difference of squares, get into some that are a little bit more challenging, and really the tricky thing with difference of squares is recognizing when you have difference of squares and how to continue factoring. A lot of times they pop up after you factored something and there's a second difference of squares or so on. So the first one we're going to look at, we have 625 minus x to the fourth. Now whenever you have two terms and you're subtracting, that should be like the light going off of this might be a difference of squares. Let's see. So 625, is that a perfect square? Well, actually yes, that is the perfect square. 625, you can take the square root, and the square root is 25. Can we take the square root of x to the fourth? Well, what times what, or what squared would be x to the fourth? And that would be, well, x squared. X squared squared would give us x to the fourth, so the square root of x to the fourth is x squared. So this is a difference of squares. And when we factor, your a term is 25, and your b term would be your x squared. So you're going to add x squared, and you're going to subtract x squared. And now when we get down to here, you have 25 plus x squared. It might jump out that these are both perfect squares. It's really tempting to factor further, but it's not a difference of squares. This is the sum of squares, so we can't factor this further. But looking over here, 25 minus x squared, that is a difference of squares, so you can continue to factor that binomial to the right. So 25, well, the perfect square of 25 is 5, so that's going to be your a term. And the square of, or the perfect square, or the square root of x squared is going to be x. So you're going to add an x, and you're going to subtract an x. So we did the difference of squares actually twice here. Second time was for this binomial. So this would be the completely factored form. Again, the tricky part can sometimes be recognizing when you need to continue to factor. You factored originally, but now you should notice that you can still continue to factor further. It's all about recognizing the patterns. So our next one, we have b to the fourth minus 16. So b to the fourth, well, that is a perfect square. B to the fourth, you can take the square root of that. That would be b squared. 16, that's a perfect square. You can take the square root, it's 4. So your a term is b squared, your b term here is 4. So that means we're going to have b squared plus 4 and b squared minus 4. Again, this is really tempting to factor, but it's an addition sign, so we can't use difference of squares. So that's not factorable. That right there, that binomial is prime. But this one over here, b squared minus 4, that is a difference of squares. You're going to end up with b plus 2 and b minus 2. So this would be our completely factored form. Again, we needed to use the difference of squares twice. Once we did it the first time, the tricky part is recognizing that we can use difference of squares for this binomial. Alright, on to our next, and then we'll solve a few equations. So our next one, we have 5x squared minus 45x. And notice we don't have perfect squares. Oh, so 5x to the fifth minus 45x. We don't have any perfect squares here, but we do have a GCF. And that really should be the first thing we're looking for. Is there a GCF? Now both these two terms, they have a 5 in common, so we can factor out a 5. And they also both have a 1x in common, so we can take a 5x out. So over here you're left with x to the fourth, and over here you're left with minus. We took a 5 out, so you have 9. You took the x out, so the x is out, so minus 9. So we have 5x, and we should notice that this is a difference of squares right here. So you took the GCF out, but the tricky part again is recognizing, well, this is a difference of squares, so we can factor further. Square root of x to the fourth is x squared, that's your a term. Square root of minus, well, square root of 9 is 3, so you're going to have a plus 3 and a minus 3. And then, well, if you're looking, we have two terms we're adding, can't use difference of squares. We have x squared minus 3. X squared is a perfect square, but 3 is not, so we can't factor this any further. this is going to be the completely factored form. If this was a 4 or a 9 or a 16 here, then we could use difference of squares, but it's a -3, so since they're not perfect squares, we're as factored as we're going to be. Okay, so let's do a couple of equations. Now incorporating some difference of squares, and we'll put in some of the old methods that we should still feel comfortable with. Our first equation is 18x squared equals 50. We want to solve for what values of x are going to make this work. So our first thing we should do, and the only method we've talked about so far, is using the zero product property, which means we need one side to equal 0. So to do that, I'm going to subtract 50 from both sides. So it'll look like this. 18x squared minus 50 equals 0. Now if we can factor over here, then we can use that zero product property. And well, let's see. Not perfect square, not a perfect square, so we can't use difference of squares, but again, the first thing we should be looking for is GCF. And 18, 50, those are both even numbers, so we should be able to factor out a 2, we'll start with, and maybe we can factor more out afterwards. So you factor a 2 out of 18x squared, you get 9x squared. Factor a 2 out of 50, you get 25. So right now, it's 2 times this quantity equals 0, but we can continue to factor. This is factorable. So, perfect square, 9x squared. Your a term is 3x. 25 is a perfect square, so you're going to have a plus 5 and a minus 5, and equals 0. So now we have 2 times this binomial equals 0. So in order for that to be 0, one of those 3 factors needs to be 0. 2 is never going to be 0, so that's not going to happen. But these binomials could potentially be 0. So our first case, 3x plus 5, if that equals 0, then this would 0 out and everything would multiply to be 0. So when we solve, you subtract your 5x, and then you divide by your 3, so negative 5/3 is one possibility for x. We also have the possibility that this second binomial equals 0. So 3x minus 5 equals 0. And when you solve for x, you'd add your 5 and divide by your 3. So x could be positive 5/3. Those are going to be our 2 possibilities here. Negative 5/3 and positive 5/3. So we have 2 solutions for this. And again, going back to the original, our highest degree in the equation is 2, so we could have up to 2 solutions for that equation. And these are the 2 solutions for us. Let's look at our next one. Our next equation, we have 16h to the third minus 9h. 16h to the third minus 9h is equal to 0. So we're close. We're equal to 0 already. We just have to see if we can factor things over here, turn it into multiplication of polynomials. So let's see. First thing we should look for, GCF. We have h's in common. Our coefficients, they don't have anything in common, so let's pull an h out. 16h squared minus 9 equals 0. And our h is out in front. Alright, so far we've factored out a GCF. Now we should recognize that this is a difference of squares here, so we can continue to factor. Square root of 16h squared, well that's 4h, so that's your a term. Square root of 9 is 3, so you're going to have a plus 3, and you're going to have a minus 3. Now in this one's a little bit different than ones we've talked about. Instead of doing like a times b equals 0, we kind of have like a times b times c equals 0. This monomial times this binomial equals 0. So if any one of these 3 equals 0, then the whole product will equal 0. So one possibility would be if the monomial equals 0. So we could have h equals 0, and that's one solution. If h equals 0 here, if we substitute 0 in for h, then it'll equal 0. And if you go back to the original equation, if you put a 0 in for h, you'll see really quickly that it does make the equation true. So this is one solution. That would be if the binomial is 0. How about if this binomial, 4h plus 3, equals 0? Well, we could solve for h. You would subtract your 3, divide by your 4, and h would be negative 3/4. So that's another solution. And then we can go over to the second binomial, 4h minus 3 equals 0. And to solve for h, you would add 3, and then you would divide by your 4, so you have positive 3/4. So your solution here would include negative 3/4, 0, and positive 3/4. And if you go back to your original equation, notice the highest degree was 3, so that means at most there's going to be 3 solutions. So we have 3 solutions here. Doesn't mean there has to be 3 solutions, but at most there could be 3 solutions, and we have those 3 solutions accounted for here. All right, on to our last equation of the day, and then you can go on trying some of these for yourself. We have x plus 5 times x plus 2 equals 40. So don't fall for the trap, because it looks like it's factored for us and everything's nice, but that only works if we're equal to 0. So unfortunately, we're not equal to 0. So in order to do this, we need to get the 40 over to the other side, but then we're not going to be completely factored on the other side. We're going to look like this if we were to move the 40 over. We would say minus 40 equals 0, and now we're not multiplying polynomials, we're multiplying these two binomials and then subtracting a constant over here. So it needs to be just multiplication between everything. So in order to do this, we're going to have to kind of simplify this side and turn it into something that is factorable. So to do that, we're going to need a FOIL here. You have x squared plus 7x plus 10 minus 40 equals 0. When you FOIL these two binomials out, you get down here, and then we subtract the 40. And now we can simplify a little bit. X squared plus 7x minus 30 equals 0. And now can we factor? Well, what I recognize when I look at this, it's a trinomial, there's no GCF, so we should hopefully be able to factor with two numbers that multiply to be negative 30 and add up to 7. Your C is negative, so if this is factorable, you're going to have a positive and a negative here. So what two numbers multiply to be 30 and add up to 7? Well, I would do a positive 10 times a negative 3, and that would work for us. Multiply to be negative 30. When you add them up, we're going to end up with that positive 7. So that means this binomial times this binomial equals 0. So either x plus 10 equals 0, which means x equals negative 10, or x minus 3 equals 0, which means x could equal positive 3. So our solution set would consist of negative 10 and positive 3. Alright, and that's all we have for today. So we have 3 methods that we can use. You should be looking for GCF, trinomials like this, and difference of squares. Tricky thing is recognizing when to use each one and being really familiar with the patterns, because it's not always going to say use difference of squares. Now you have to recognize when to use that, when to use a trinomial, when to pull out the GCF. So it's all about being comfortable and knowing the patterns. Alright, have a nice day, guys.